This is a hypothesis test for mu, the population mean, and we're going to be using the p-value method. A special cable is claimed to have a breaking strength of 800 pounds. The standard deviation of the population is 12. A researcher selects a random sample of 20 of these cables and finds the average breaking strength is 793 pounds. Can he reject the claim that the breaking strength is 800 pounds? We're going to use an alpha of 0.01 and assume that the variable is normally distributed. We know in this problem that the population standard deviation is 12, and so that tells us that since we know the population standard deviation, we will be using the z-table. And then we also have an alpha. This is the significance level of 0, 1. We'll be using that. And we are also looking at what the claim is. And the claim here is that the breaking strength is 800 pounds. And is means an equal sign. So when we go to set up our hypotheses, the claim is going to go with the null, which is that mu is equal to 800 pounds. They're claiming it is actually equal to that. The alternative would be that the claim is not equal to that. So that's the alternative hypothesis. When we do the p-value method, the next step is to calculate the test value. And so we are using the z-table because the population standard deviation is known, and we'll be calculating a z by using this formula. And the sample mean that they got from their sample was 793. We're subtracting away the hypothesized mean. The population standard deviation was 12 over the square root of the sample size, which is 20. When I do this on my calculator, I'm getting negative 2.61. That's my test value. On the p-value method, what we do is we look up that test value on the table in order to find the p-value. So what we're really doing is we're going to our z-table and we're looking up negative 2.61, and we're going to find this area going to the left of it. Let me bring up the z-table, and we will, let's see here. When I go to the z-table and I look up 2.61 right here, it's right here, whoops. 2.61 shows an area of 0.0045. So this area is 0.0045. This is a two-tailed test, and on a two-tailed test, you take that area that's in the tail of the test value and you double it. And that's your p-value. You only have to do this on a two-tailed test. That's where you double. And the reason we know this is a two-tailed test is because of the equal, not equal to. And so the p-value is 0.0090. And then on the p-value method, the way you make your decision is you compare the p-value to the alpha. And so I'm comparing this p-value to the alpha that's in the problem. And whenever the p-value is less than the alpha, you reject. So we are rejecting the null hypothesis because the p-value is smaller than the alpha. And then let's look back at our hypotheses. We are rejecting the null hypothesis, and as we reject it, we are also rejecting this claim that the breaking strength is 800 because the claim is associated with the null, which we are rejecting. So back down here on this sentence, we are also saying there's enough evidence to reject the claim that the breaking strength is 800 pounds. We don't think that's true anymore. We're rejecting that claim.